In this video, inverse trig derivatives part 2, our inside function is going to be a fraction, which will give us some additional algebra that we can do. So in our first example, notice chain rule applies. We have dy dx is equal to derivative of inverse sine 1 over root 1 minus, don't change the inside, so we have a 1/2 x multiply by 1/2. So dy dx is equal to 1 over, now notice this 2 is on the bottom, so I'm going to leave that on the bottom, root 1 minus 1/2 x times 1/2 x is 1/4 x squared. Here is where our algebra can get a little more complex. So if we take a look at that, on the inside of the square root, we can make a common denominator. If I make a common denominator there, I have 1 over 2 root. I'm going to turn the 1 into 4 over 4. That's going to allow us to rewrite the inside as 4 minus 1x squared over 4. Now, why the heck would I want to do that? Well, if you remember from your Algebra 2 days, this bottom then, if I only look at the bottom, I've got 2. I can rewrite that radical as 2 separate radicals. And notice then, the square root of 4 is 2, and we can cancel out the 2's. So my final answer would be 1 over root 4 minus x squared. Let's look at a second example. In this case, we're taking inverse tangent derivative. Chain rule applies. So dy dx is equal to, we have 1 over 1 plus, don't change the inside, multiply by the derivative of the inside. Now notice there's no square root involved this time, but we are going to have some additional algebra. So let's look at this as 1 over 4, and we've got 1 plus 1/4 x times 1/4 x is 1/16 x squared. Now again, I'm going to want to make a common denominator. So if I make a common denominator, I've got dy dx is equal to 1 over 4. I'm going to turn that 1 this time into a 16 over 16. So I've got on the inside 16 plus 1x squared over 16. Again, I say, why the heck would we want to do that? Well, notice that this 4 can cross out that 16, making a 4 on the bottom. I now have a complex fraction, dy dx is equal to 1 divided by 16 plus x squared over 4. With division, remember you multiply by the reciprocal of the bottom, so 1 times the reciprocal would give us 4 over 16 plus x squared. And that would be our final answer there. In our third example, we have inverse secant. Chain rule applies. So dy dx is equal to derivative of the outside 1 over absolute value, don't change that inside function, multiply by, and then we've got again, don't change that inside function, and then times the derivative of that inside function. Dy dx equal to, notice this 2 is on the bottom, so I can multiply it over here. If I multiply it over here, notice that these 2's cross out. I have 1 over absolute value of x square root of 1/2 x times 1/2 x would be 1/4 x squared minus 1. Now again, I do want to make a common denominator on the inside. So I've got 1 over absolute value of x. Now again, the common denominator, this 1 turns into a 4 over 4. So I'm going to think of it as the square root of 1x squared minus 4. And I'm going to do that trick from Algebra 2 and write it as 2 separate square roots. So that's going to give me a 4 on the outside. Now notice the square root of 4 is 2. So I can write that like this. I now have 1 over absolute value of x root x squared minus 4 divided by 2. Again, that's a complex fraction, so we're going to multiply by the reciprocal. We get a 2 on top, absolute value x root x squared minus 4 as our final answer.